All right, so for recognizing s and p orbitals, you're just going to be expected to know what the shapes of those orbitals look like. So an s orbital is spherical, like so, and there's only one way you can draw a sphere, right? So out of the orientations, etc., there's only one possible way, and that also is coming from that there's only one possible value of ml when L is 0, which is ml equals 0. So that is our lovely s orbital shape. For p orbitals, p orbitals have L equals 1, which means ml can equal -1, 0, or +1. So there's three orientations for p orbitals along the x, y, z Cartesian axes, and I'm going to try and draw these the best I can. Okay, so these are like a kind of double dumbbell type shape. So this direction, and I might have to freestyle the other to get the right angle, I think. Ooh, we'll try it. Sort of on an angle. No, that's not going to work. Let's try you. And we can just imagine that we're shading it in. Okay, so as far as like along Cartesian axes go, the general definition would be that this is the z-axis, I believe. Depends on your textbook. I think your textbook calls this the x, and this the y, and this the z, now I think about it. Some textbooks call this one the z for the bonding axis, but not this one. So this would be my px. That's supposed to be a subscript, but we'll do. This would be the py, and this would be the pz. Okay, so three kind of dumbbell type shapes. Now, d orbitals are related to p orbitals. So remember, d orbitals will have L equals 2, which means your NL values go from -2, -1, 0, +1, +2. So there are 5 possible orientations for the d orbitals. Now, you don't have to recognize them on this question, but you'll occasionally see them come up. So they're the same kind of shape as p orbital, like if you had two of them sort of like crossed. So I'll just do a generic D like this. So there's 4 out of 5 that have this kind of shape, okay? And the labeling for them just depends along which axis or between which axis these lobes are aligned. And then the 5th one is kind of funky, where you have like a p orbital, like it's got stuck in a donut. So there's also like a donutty kind of shape one going around. So that is the 3DZ, okay? Just in case you see those come up. Okay, so looking at what we have here, it looks to me like we have a p orbital, another p orbital, an s orbital, and then just a donut, right? It's applying to nothing. In terms of the different size, remember that as n gets bigger, the size of the orbital gets bigger because there's more electron density further from the nucleus. And you can't see on here, but they also do have radial nodes, which increase with the value of n. So like a 1s orbital will have 0 radial nodes, but a 2s will have 1 radial node, n-1 radial nodes. 3s will have n-1 radial nodes, will have 2 radial nodes, etc. So are any of them s orbitals? Well, that would be a yes. Do I get a check mark here? And the s orbitals listed here would be the C. Are any of them p orbitals? Also yes. And both A and B are p orbitals. So that is how I would go about answering that question.